Hey guys, this is Srini and you're watching Python tutorial videos on my YouTube channel Python for Microscopists. In this tutorial, I'm going to talk about ridge filters for your image processing. And what are ridge filters? As the name suggests, they're designed to detect ridge-like structures. Okay, and these can be your neurites or the veins that are actually going through the leaves or anything that's actually a ridge-like structure. For remote sensing, you can actually see these rivers, that are flowing through. So these are the ridge-like structures, and these filters again are supposed to be highlighting these areas. Although I should say, based on my past experience, I never worked on any sample or any image that required this ridge filtering, but again, I'm recording this short video just to make sure you all know that something like this exists in case you work with these type of samples. Okay, so let me jump into the Python code right now, and I've already written the first few lines, so we can just go ahead and import the required libraries. And I don't know, I keep importing the filters, but then I import specific filters anyway. So, but that's okay. Uh, Now, these filters are available in Scikit-image filters, and there are four of them, at least as of 2020, as part of the Scikit-image filters, ridge filters, and these are Meyering, Sato, Frangi, and Hessian. Now, like I mentioned, I do not have enough experience with any of these. The only thing that I've actually used was Hessian in the past, and not to extract ridges per se, but as one of the feature extractors for my machine learning algorithms. By the way, any of the filters that I'm talking about, they're not just to extract, something, or they're not just to convert your image, one image, two images. You can in fact use all of these as your feature extractors for your machine learning, pipelines. So knowing what these do is very important information, even though you may not be working on these type of samples. So uh, let's go ahead and import or read our images here. And again, I'm using Scikit-image io.imread, and I downloaded a leaf image from Google search just so I can show you exactly how it looks like here. I believe this actually, all of these work only on a gray level image. That's why I'm actually converting my RGB image into gray. Again, there are a million ways you can do it in Python. So this is the one I just picked. So as other filters, this is very easy. So for mirroring, you just apply mirroring onto your image and so on. So again, why watch me type all that boring stuff? So I've already did this in my notepad. Let me copy from my notepad, paste it here. So mirroring image is nothing but we imported this mirroring there, and mirroring, and apply it on your image array. And that's it, you're done. And let's go ahead and plot it. And just like the previous couple of tutorials, I'm going to use pyplot to arrange my results as a grid pattern. So here again, 221, I'm putting the original image and the mirroring image, Sato image, Frangi. Uh, do I have Hessian? Maybe not. We can also include Hessian, actually. Sorry about that. But let's look at this. I don't want to type this again. So let's go ahead and run this and see how the result looks like. So here you go. So as you can see, here is my input image. And here is the mirroring, here is the Sato and Frangi right over there. It's tough to see it here, but uh, maybe I'll zoom this in the video. But you can see these are the outputs. And again, try this on your own sample and see how it works. In fact, let's actually change this to Hessian and see. Uh, Hessian, and okay, so let's go ahead and look at the Hessian image. Okay, so as you can see, apparently it's actually cutting down, the pixels right around the edges where it's touching the edge. But Hessian, as you can see, the reason why I used Hessian in the past for my machine learning purposes is compared to all of these, it actually gave me a much better representation of these veins that are actually going through. And maybe that's why Hessian is a bit more famous than all the other ones. So now you know that something like ridge operators actually exist and how the output looks like in a way from each of these. And hopefully you'll apply these to your samples and find at least one of these to be useful for your research or work purposes. Thank you very much for watching this tutorial, and please subscribe to my channel. Keeps me encouraged, and let's talk again. Let's meet again in the next tutorial. Thank you.